Come, let's go into the electrical energy supply system. It contains many different category on power station with respect to time. That is elements of power supply system or generating station, primary transmission, secondary transmission, primary distribution, secondary distributions. Those five categories can have system load of broad categories. That broad categories: domestic, commercial, industrial, agriculture, and others having some street light traction, etc. Now, let us see per unit conversion procedure. Pick, pick a one frequency voltage amps base for the entire system SB. That conversation and transmission of load, the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. It is the ratio of kilowatts generator to the product of plant capacity and the number of hours for which the plant was in operation. That factorization can have station output by plant capacity and hours of use. Then calculate the impedance base, calculate the current base, convert actual value to per unit. Per unit in the sense conversion on affects magnitudes, not the angles. Also per unit quantities no longer have units. Then load flow analysis. Objective of this load flow analysis having voltage, magnitude and phase angle at each bus. A real and reactive power flowing in each elements. Reactive power loading on each generator. That means the various peak curves of generation, the area under the load duration curve is equal to that of the corresponding load curve. That means the factorization always having depends upon the generating equalization. That level with representation of load flow analysis. That load flow analysis meant the governor which can carry a device used to control or the speed of a prime mover. A governor protects the prime mover from overspread and keeps the prime mover speed at or near the desired revolution per minute. When a prime mover drive an alternator supplying electrical power at a given frequency, a governor must be used to hold the prime mover at a speed that will yield this frequency. An unloaded diesel engine will fly to pieces unless it is under governor control. Load frequency control always sends the busbar frequency and power frequency. Then difference fed to the integrator and to speed changer if the die line frequency always maintain constant. This is fault types. There are two main types of fault. One symmetrical fault, another one is unsymmetrical fault. Symmetrical fault in the sense always system remains balanced. These faults are relatively rare because the symmetrical fault always can give a minimum number of fault, reasonably minimum number of fault compared than unsymmetrical fault. Unsymmetrical fault is no longer balanced. It is very common but more difficult to analysis. The most common type of fault on a three-phase system by FAR is the single line to ground, followed the line to line faults, then double line to ground faults and balanced three-phase faults. Lighting strike event sequence, or a lighting hits a line setting up an ionized path to ground. That means where the lightning hits line, a single typical stroke might have 25% or 25,000 amps with a rise time of 10 microseconds, just 10 microseconds dissipated in 200 microseconds. Multiple strokes can occur in a single flash, causing the lightning to appear to flicker. So the flash with the total event lasting up to a second. Conduction path is maintained by ionized air after lightning stroke energy has dissipated. So the resulting in high fault current often greater than 25,000 amps. Within one to two cycles, that is 16 milliseconds, relays at both end of line detect high currents, signaling circuit breaker to open the line. Nearby location or decreased their voltage level. Then the circuit breaker open to de-energize line in an additional 1 to 2 cycles. Due to that, breaking tens of thousands of amps of fault current is no small feat. With line removed, voltages usually return to near normal. Circuit breaker may reclose after several seconds, trying to restore faulted line to service. Fault analysis. Fault may be analysis under the control of current and magnitude. So fault current cause equipment damage due to both thermal and mechanical process. Then goal of fault analysis is to determine the magnitude of the current presenting during the fault. So need to determine the maximum current to ensure devices can survive the fault. Need to determine the maximum current the circuit breaker need to interrupt to correctly size the circuit breaker. Then generator modeling during fault. During a fault condition, the only devices that can contribute fault current are those with energy storage. Thus, the models of generator and other rotating machines are very important since they contribute the bulk of the fault current. Generators can be approximated as a constant voltage behind a time varying reactance. This is a graphical representation of fault identifying fault system. It has to segregate three. One is subtransient period, transient period, steady state period. That subtransient period always occurred, subtransient envelope. The transient period always overlap transient envelope. Steady state period envelope, steady state envelope. So the time varying reactance is typically approximated using three different values, each valid for a different time period: xt double dash, xt dash, xt. Xt double dash in the sense direct axis subtransient reactance, xt dash direct axis transient reactance, xt direct axis synchronous reactance, synchronous transient subtransient. Those three categories under the control of this reaction. Can then estimate current using circuit theory. For example, could calculate steady state current that would occur after a three-phase short circuited if no circuit break interrupt current. Already we had seen this picture. So this is fault current transient in machine. We have three fault transient, substantial or subtransient period, a transient period, steady state transient period. Those periods marked by this graph having two axes. X-axis takes t linear, t in the sense time, y-axis takes current logarithmic scale. So while the power system operation, this fault current transient occurred across that system machine. So we had picked this variation from that operation. This is power system analysis. Power system analysis having two classifications on steady state and dynamic state. Uh, Under the steady state, having two subtopics: network normal, network faulted. So each network having two subsystem, balanced and unbalanced. So dynamic also network normal and network failed. So those categories are working under the control of power system analysis. Effect of fault and power system: the flow of excessive current, abnormal voltages, voltage elevation of system neutral, induce over voltage on neighboring equipment, hazards to human equipment and animals. The need for fault analysis. Design of protection system require the knowledge of fault current. The information obtained from the fault studies are used to select the size of circuit breaker, then fuse and its characteristics, setting of protective relay. This is types of asymmetrical fault current across the transmission line, uh, schematic representation. Then need for the symmetrical component analysis. Negative sequence relay in generator help in protecting the generator from overheating. In the event of unbalanced loads, the positive sequence segregating network is used to supply the sensing voltage to generate voltage regulators. Certain connection of CT and PT develop zero sequence components that are used in protective ground relaying scheme. Then we can look a phasor or operator. Phasor notations of operator: A equal to 1 by 120. So we take that each phase 120, each phase angle between those two phases or 120. So we can get and calculate e power j 2 pi by 3. This is mathematical function of that phase angle difference. A square equal to 1 by angle of deflection minus 120. A cube equal to 1 by 0. A power 4 equal to a power 5 equal to a square. This representation under the control of phase angle difference between two phases. The positive sequence set consisting of three components of equal magnitude displaced by 120 and 240 respectively, and having the phase sequence of ABCA the same as that of origin phasor. Negative sequence set consisting of three components of equal magnitude displaced by 240 degree and 120 degree respectively, having phase sequence of ABCA. Then the zero sequence set of the component of which being equal both in magnitude and phase. Thank you.